Hello and welcome to Transfer Learning with PyTorch. Now, this is one of my favorite topics in all of machine learning, so let's get started. First of all, where can you get help? Number one is to follow along with the code. PyTorch Transfer Learning, we're going to go through Google Colab and we're going to be writing code together. Remember the motto, if in doubt, run the code. Try it for yourself. Press Shift Command and Space to read the doc string, but if you find it's hard to read in Google Colab, you can always go to the PyTorch documentation. And if you're still stuck, well, you can ask a question on the course GitHub discussions page. If you come in here, it's pretty empty right now because the course isn't out yet as I record this video, but you can click New Discussion, put in your info there, and then someone can help you out here. And of course, we've got the course GitHub with all of the materials. This particular notebook is going to be number 6. Right now, as I record this video, there's 2 versions of this, but by the time this video is out, it's only going to be 1 version. I've made 2 versions because what we're going through uses the latest PyTorch versions, so I had to upgrade the original one. And then we've got all of the course materials, and then of course, we've got learnpytorch.io, which is the book version of this course. See how we've got V2 and this one doesn't have a V? Just by the time this comes out, it'll only be 1 version. I had to make V2 because this is the updated version of what was originally going to be in there. So without any further ado, let's get into the keynote. You might be asking, what is transfer learning? Now, we've built a few models so far, but you might be thinking as well, surely someone has spent the time crafting the right machine learning model for the job. And in fact, that's exactly what transfer learning is. So let's have a look at some examples. So we're working on a computer vision problem, and we are because we're working on Food Vision Mini right now, a neural network to take photos of food and classify them. Now, what if you had a large data set of images? For example, there's a data set out there called ImageNet, and a lot of people have trained computer vision models on ImageNet, and in fact, there is actually a challenge, well, there was a challenge until it sort of neural networks got too good for ImageNet. This one has close to 14 million or just over 14 million images. But the traditional ImageNet dataset has just over 1 million images of 1,000 different types of classes. So you train a neural network on that. And then what if we could use the patterns in that neural network that is trained on 1 million images, but then customize those patterns for our own problem, specifically for Food Vision Mini? So that's an example of transfer learning. You're taking what one model has learned, for example, a computer vision model on a large data set like ImageNet, and then customizing it for your own use case. And so if we look at natural language processing, which is the idea of using a model to find patterns in natural language text or natural language full stop, what if we had a neural network that is trained on all of Wikipedia to create a language model? Then we could use what that model has learned about the structure of language itself. So, for example, where a certain word should be in a sequence of a sentence, such as the word, the something jumped over the fence, the something will be more than likely be a dog than a car, for example. Then we could customize that model to make a spam engine to predict, is this email spam? Well, I don't think it is because, hey, Daniel, this deep learning course is incredible. Wow, thank you so much for the kind words. I can't wait to use what I've learned. Feel free to send me that email if you want. That is my actual email. But this is spam, so if you try to send me this email, actually, try to send me this email and see what happens. So I want to see if that actually gets classified as spam. But the overall pattern here, what we're seeing with transfer learning, well, the main takeaway from transfer learning is we take what one model has learned on one data set, usually a large data set. The term is pre-train that model on that large data set, such as all of Wikipedia, or such as all of the images in ImageNet. And in fact, there are larger data sets out there now than just ImageNet or all of Wikipedia. So our model learns patterns / weights / parameters from a similar problem space to our own. And then the power of transfer learning is that we can use these pre-learned patterns and we can tune them to our specific problems, such as using the ImageNet weights for Food Vision Mini, or such as using the language model from a model reading all of Wikipedia to create a spam or not spam email engine. So let's keep going forward. Now, I've kind of hinted at this question already. Why use transfer learning? Well, let's start with a couple of dot points. You might have gathered this. We can leverage an existing neural network architecture proven to work. So when we built TinyVGG, we were crafting a neural network architecture layer by layer. So the benefit of using transfer learning is that typically some smart researchers have already crafted neural network architectures proven to work on problems similar to our own. So that is one of the main key benefits of transfer learning. And of course, if we leverage a working neural network architecture, we can also leverage the existing learned patterns on data similar to our own. And so this, as we'll see, often results, oh well, that's a spoiler. Oh my goodness, Daniel, don't give away all the tricks yet. Often results in great results with less data. So that's the power of transfer learning. Use an already existing neural network architecture, proven to work, and because it has already learned some patterns, if we adjust those to our own problem, we can often get great results with little data. And so, here's this in a graphic form. We learn patterns in a wide variety of images. So that gives our model an underlying understanding of the structure of what's generally in an image. So for example, a pre-trained efficient net. Efficient net is a computer vision architecture. It already works really well on computer vision tasks. And so we might want to extract those pre-trained patterns from efficient net and tune them, the patterns / the weights, to suit our own problem. Food Vision Mini. This is what we're going to be building throughout this section. And so, ideally, if we do that, if we extract the patterns from a pre-trained model, our model that we've tuned to our own use case performs better than a model just trained from scratch, such as what we did with TinyVGG. And so, another reason to use transfer learning, this is a recent research paper, How to Train Your VIT, which stands for Vision Transformer. And I'll let you read through the whole paper if you'd like to, but I'm not going to read this verbatim. If you're interested in being a machine learning practitioner, this is the most important line here. Most practitioners, however, rarely if ever perform pre-training on today's largest data sets, but instead use some of the many publicly available parameter sets. And that is the beautiful thing about machine learning, is that there are so many places now where you can find publicly available parameter sets. And what they mean here is you could swap this out for publicly available pre-trained models. So if you're interested in being a machine learning practitioner, you'll be looking for places where you can find publicly available pre-trained models. There's another quote from this same paper, which is more about the results. So we conclude that across a wide range of data sets, this paper explored how to train a vision transformer model with data augmentation, regularization, and a whole bunch of transfer learning. So we conclude that across a wide range of data sets, even if the downstream data of interest appears to only be weakly related to the data used for pre-training, so recall that we said ImageNet, a whole bunch of images, we can use that for our food vision problem. Transfer learning remains the best available option. Oh, that is beautiful. I love that line. So even if your downstream data, your custom data, so your custom problem of interest appears to only be weakly related to the data the model was used on pre-trained, transfer learning remains the best available option. And I'm going to finish here with one more quote of why to use transfer learning. I'd rather see this in action. And this is from the video, Most Research in Deep Learning is a Total Waste of Time, by Jeremy Howard from AI Podcast with Lex Friedman. Now, watch the whole clip or the whole video to get this. This is a little bit out of context, but this is the quote I've ripped from this video. The things that really make a difference, transfer learning, if we can do better at transfer learning, it's this world-changing thing. Suddenly, lots more people like us can do world-class work with less resources and less data. Now, that is from Jeremy Howard, the founder of Fast.ai, one of the best places to learn AI on the internet. So that's enough of why use transfer learning. Oh, actually, one more. Do you remember our improving our model slide from a few sections ago? I can't remember how far we've come. We've come a long way. So the method to improve a model, reduce overfitting, we could add more data. We could use data augmentation. We could use better data. Or we could use transfer learning. So we could take an existing pre-trained or pre-learned patterns from one problem and tweak them to suit your own problem. Now, okay, that's enough. I've spoken too much about why use transfer learning. Let's, in the next video, cover a few places where you can find pre-trained models. I'll see you there.